So the last three problems are 7, 8, and 10, because I skipped ahead and did 9 out of order. So 7 says, state the factored form. These are two very special terms. And the reason these are two very special terms is because of 8 and 27 both being cubes. All right, they are both cubes. 8 is 2 cubed and 27 is 3 cubed. So you should have some alarms going off in your head that says, hey, these two numbers, because they are cubes, might behave differently. And in fact, here's exactly how they're going to behave differently. When you're asked to factor 2 cubes, let's say you've got a cubed minus b cubed. They will always follow the following pattern. A minus b, a squared, ab, b squared. Same sign that you started with, opposite sign, always positive. So if you can break down what your cube roots are, you can plug in those cube roots to the factor pattern and not have to do much work at all. Same goes for a cubed plus b cubed. If you can figure out what your cube roots are, like 2 and 3, you can plug them into the pattern a plus b, a squared minus ab plus b squared. And these patterns will hold true to any pair of cubes. So if we look at 8m6 and 27p cubed, we can go ahead and say, hey, 8m6 is really 2m squared raised to the third power. And 27p cubed is really 3p raised to the third power. And what this does for us is it sets up the circumstance where a is 2m squared, and b is 3p in the pattern right here of a cubed minus b cubed. So to factor number 7, we simply plug in 2m squared and 3p because those are the cube roots of 8m to the 6 and 27p cubed. So your final answer here should be 2m squared minus 3p for your first parenthesis times a squared, so 4m to the 4th, because you got to take 2m squared and you got to square it, minus, now we're going to multiply them together, 2m squared times 3p minus 6m squared p, and then b squared, 9p squared. And there are our two parentheses to factor these pairs of cubes. And we're going to repeat that same process for number 8. So first things first for number 8, I am going to go ahead and take out the GCF of -5 because they can both be divided by -5. Always check for those GCFs. Leaves me with x cubed plus 125. X cubed, there we go. And those are made up of x cubed plus 5 cubed. So we are now, for number 8, going to be following the second pattern. Number 8 will follow the positive pattern, which means that we'll have -5, GCF still chills on the outside. A is x. If you need to write off to the side, right off to the side, a is x, b is 5. X plus 5, x squared, right, because it's a squared, and then minus ab, so minus 5x, and then plus b squared, so plus 25. And there you go. I wasn't kidding. If you know what your cube roots are, you can just plug them straight into the factoring pattern and do very little work. All right, Last one is number 10, and number 10 says to solve. Well, there's a couple of things that we can do here. And first, I'm going to go ahead and just say, you know what? We're going to check it in Desmos first. We're going to see if we can solve this with the graph. So when I look at this, x cubed plus 2x squared plus 5x plus 10, I unfortunately only have one nice solid answer, -2. So I know for sure I've got an x equals -2 answer. That means that maybe I have to solve with factoring. So I'm going to go ahead and group them up. Anytime you have to do some factoring that you don't like, we got to group them up. All right. So I'm going to look for common terms. Well, both these first terms have x squared in common. So I'm going to take out x squared. I've got x plus 2. Okay, that might be helpful because the second two terms have 5 in common. So I can take out 5 and oh, look at that, x plus 2, still there. So now I know, since they both have x plus 2, that's one factor. And then x squared plus 5 is my other factor. So I still have the equal to 0. But when I transfer this to my work page, because yep, I'm out of room already. All right, bear with me. There we go. All right, when I transfer this to my work page for number 10, x plus 2 equals 0 and x squared plus 5 equals 0. I take each factor and I separate them equal to 0. Now I can solve for x, and that confirms my -2, x equals -2 answer. There's one answer, and I confirm that from the graph. Yay! Now the other answer, -5, x squared equals -5. Take the square root from both sides. And anytime you solve with the square root, you must put a plus or minus in front. That's because of the fact that, let's say we're dealing with, so we had x squared equaled 49. Well, 7 squared gets you 49, but so does -7 squared. So regardless of it being positive or negative, it still got you 49, which means when you solve to find out which one it was, you don't know which one it was, you have to say it could have been both. So we put plus or minus the square root of -5, and this is why we didn't see it on the graph. It's imaginary. Square roots of negative numbers are imaginary. So that's why on the graph, we only saw the single answer of -2. All right, that's it for your Unit 4 test review. Exam review. There are more practice problems on Canvas if you want to click on any of those worksheets.